Hello, in this video I will be talking about rotation and specifically looking at angular momentum. So like momentum, which describes how difficult it is to stop an object from moving linearly, angular momentum describes how difficult it is to stop an object that is rotating. So the symbol for angular momentum looks like this, and a common formula for it is the following: equals r times p, where r is the radius or distance and p is the momentum. Something else that's important to consider, or another formula that can also apply to angular momentum, is that it equals to I times W, where I is the inertia and W is the work. So now that we've got a good base for what angular momentum is, we're going to go ahead and apply it to a specific real-world example from an AP exam. So first I'm going to read it. A particle of mass 2.0 kilograms is moving in the xy plane at a constant speed of 0.80 meters per second in the positive x direction along the line y equals 4 meters. As the particle travels from x equals negative 3 meters to x equals positive 3 meters, the magnitude of its angular momentum with respect to the origin is blank. So, given this formula and the information we're given, so we know that the particle has mass is equal to 2.0 kilograms. We know that the speed is 0.80 meters per second. We also know that it's moving in the positive x direction along the line y equals 4. Positive x direction along y equals 4. So we also know that so from this we can deduce that r is going to be equal to 4, because this is essentially telling us that the radius from the center of the object, that is the particle that is rotating, is 4. And we also know that the particle travels from x equals negative 3 to x is 3. Negative 3 to positive 3. So given what we know, we can go ahead and calculate momentum, given that we have m and v, and the formula for momentum is m times v. So I'm going to go ahead and plug in mass, which is 2, and velocity 0.80, and we yield 1.6 kilograms meter per second. And then we also know we already have what r is, so we can go ahead and really quickly actually solve for L. So we know r is 4, and we know that momentum is 1.6. 4 times 1.6 is about 6.4 kilograms meters squared per second, which corresponds to option D in the exam option answers. Thank you.